Hello everyone, so in this video we'll be looking at integration by differentiation and how we can actually differentiate a given function to find the integral of a function that we don't know, generally because there isn't really an explicit product or chain rule when you're integrating functions. So I've got two examples here, as you can see, and I've got a general method for you outlined. So let's have a look at these. What we'll do is we'll start with a general method. I'll just read it through and it will probably make more sense when we start getting into examples, but the general method is to first differentiate the function given, then set the integral of the f prime of x equal to the f of x plus the integration constant. Again, you'll see what I mean by that in a minute. And then you can move any constants out the front of the integral, or split up the integral in any way that you need to, or use algebraic manipulation to find the desired integral. So rather than me blab on about the method, let's get into it. Let me show you how to do number 2, because that's probably the easier of the two here. Oops, sorry for knocking the camera there. So what we actually want to do here is we want to differentiate this function first. So we have y equals x squared plus 4x for 3 plus 5x. Again, we can differentiate that. It's just using the power rule to differentiate a few terms. And what we get is we get dy on dx equals 2x plus 12x squared plus 5. Okay, so what we do is we move on to step B, set the integral of the f prime of x. So we write that expression, the dy dx, the f prime of x, under the integral sign there. And then we set it equal to the f of x plus the integration constant c. So we set it equal to y, obviously, it's just a notation I'm using there. And so we set it equal to x squared plus 4x to the 3 plus 5x, and of course plus c. We must remember that integration constant. Again, derivatives and integrals are opposites, so the antiderivative is generally the integral. The derivative, as you know, is just the slope of the tangent, or representative of that in a function form. So now what we can see is, well, hang on, we want to be able to find the integral of this, 24x squared plus 4x plus 10. What we've got here is we've got 12x squared plus 2x plus 5. What we can see is that 24 is 2 lots of 12, and we can see that 4 is 2 lots of 2, and 2 lots of 10 is 5. So really, solving this integral is simply just a matter of actually putting a 2 out of the front and multiplying everything by 2. So we can write this expression as being 2, let's see, integral, then writing a function again. And what we do on the right-hand side is the same as what we just did on the left-hand side. So again, multiply it by 2. And now what we get is we get an expression of the integral, which is the desired integral, the one we have to find, because again we just multiply everything by 2. And what we see here is that we just expand it, and we have actually differentiated to solve this integral. Okay, so there we have it. There is our actual answer to question 2. So we differentiated to get the f prime of x, or dy dx first. We put the dy dx under the integral, and then we wrote out the f of x next to it. Then we just either multiplied it by a constant or split the integral. In this case, we multiply it by a constant in order to get the desired integral. And then from there, of course, we've got the answer, so we're able to integrate it, which is excellent, because as you can see here, the highest power here is 2 for the integral, highest power there is 3. So that's always good, because remember, when you integrate something, the power always goes up by 1. Same as when you differentiate something, the power always goes down by 1. So that's nice and simple. Again, if we wanted to check this, we could just differentiate that function, and then we should actually get the integral, of course. Okay, so now let's have a go at this one. This one involves splitting the integral, which is a technique that I will show you. It's probably something you're not really that familiar with, but we'll do it anyway. So what we have now is we have the actual y of x ln x, so we need to find the dy dx of that. So when we differentiate it, we're going to use product rule. So again, we've got x ln x, so we take the derivative of the first term, derivative of x is 1, and so we just got ln x, which is the second term as is, plus, and then what we do is we leave the first term, but then we take the derivative of the second term. And the derivative of ln x is 1 on x. So what we can see here is that this x and that x cancel. And what we do is, again, like before, we put that dy dx under integral sign. So the ln x plus 1 integral with respect to x is equal to the original function, ln x, x plus c. But we just want to find what the integral of ln x dx is. What we can actually do, you probably remember this with the sum rule in differentiation, is we can actually just, instead of differentiating individual terms, we can actually integrate individual terms. So we can actually split this into two separate integrals. So I'm going to split it into ln x dx plus integral of 1 dx equals x ln x plus c. And then remember, we want to get this left-hand side just for that integral because that's what we're trying to find. So I'm going to chuck this fella onto the other side. And the integral of ln x dx equals x ln x. Take, again, we're swapping the signs because we moved it across, 1 dx plus c. Okay, and then lastly, we actually know what the integral of 1 dx is, so integrating 1 with respect to x, so we can actually simplify that down. So we get that the integral of ln x dx is x ln x take x, of course that's what the integral is, because we raise the power by 1, imagine there's x to 0 there, we just raise the power by 1 and divide it by 1. And hey presto, we have got the integral of ln x with respect to x. So anyway, there's a video on integration by differentiation, a nice little neat concept with 2 examples there. Again, practice is key with this, but I've introduced you to using constants to manipulate it and using algebra and splitting the integral in order to find the actual desired integral. Again, it helps because there's no chain rule and no product rule within integration by differentiation. So these are just basic examples. You can find many more examples online where you look at actual things like maybe integrating x e to the power of something, because again, we don't have that product rule, so it's not easy like it is with differentiation. But again, a very neat little concept and quite an interesting one too. If you have any comments, leave them below. Elsewise, subscribe, and I'll see you in the next video.